Dear students, now we are going to discuss about Hall effect sensor. So in the Hall effect sensor, it is used for contactless magnetic sensing in IoT and automotive systems, and also some industrial sectors they are using this Hall effect sensor. So what is the principle of this Hall effect sensor means? They convert magnetic field variation directly into electrical signal through a fundamental physics phenomenon. So the main principle of Hall effect sensor is convert magnetic field variation directly into electrical signal. So now see here. So this is the diagram of Hall effect sensor. So here we have magnet part and the Hall sensor part, and we have the electrical supply. So here, so whatever that magnetic field energy is absorbed by this Hall sensor, that will be converted to electrical signal. So so what is the main principle involving in the Hall effect sensor means when a constant electric current flows through the attain the conductor and the magnetic field applied is perpendicular to it. So the relationship between here electrical current and that conductor is it will be perpendicular with each other. So now the magnetic field exerts a Lorentz force on moving charge carriers. So now see here the charge separation how it happened. The force pushes electrons towards one side of the conductor and creating the buildup of negative charge on the other edge and leaving a positive charge on the opposite edge. So like that only here the charge separation happened. So now here the very important part is Hall voltage. So so here the Hall effect part is Hall voltage part is very important. So now you might seen in this diagram. So the charge separation that Hall sensor the top of the place it has positive charges and that below that we have negative charges. So now how this Hall voltage created means the separation create the measurable potential difference across the conductor. It is known as Hall voltage. So this voltage is directly proportional to the strength of the magnetic field and also that current density. So again, in that Hall effect sensor, this Hall voltage part is very important. So already we have discussed about the charge separation. So the force electrons will be separated. The Hall sensor, the top, the positive charges and negative charges. This separation create the potential difference across the conductor. It is known as the Hall voltage. So this voltage is directly proportional to strength of magnetic field and current density. So now see here that Hall effect sensor, how they are using here. So this is the real picture. See here that permanent magnet we are placing here and Hall effect sensor and the trigger wheel. So now this magnetic energy is converted to magnetic field energy is converted to electrical energy. So through this gap. So now this Hall effect sensor, so normally it is called as Hall effect ICs. So here there are four elements. The first element is Hall element, second element is voltage regulator, third thing is differential amplifier, and the fifth thing is schematic trigger. So now see here what is this Hall element means that thin semiconductor plate placed in that between that nearby gap, so that material is gallium arsenide or we can use that indium antimonide, and the voltage regulator is used to ensure a stable power supply for consistent reading. And here we are use the differential amplifier also. It will boost the raw Hall voltage, which is typically in the microvolt range to usable level. And the next thing is schematic trigger we are using for the digital values. Add histories to prevent rapid output switching near the deduction threshold. Sometimes when you are on that particular yeah, devices, it will be on and off condition. If it is continuously having, we have that trigger this hysteresis uh, values. So for that we need to prevent this like that rapid output switching. We need to do this schematic trigger. And what are the types of Hall effect sensors? Means linear sensors, digital switches, and latching switches. So they provide a continuous voltage output proportional to the magnetic field strength, then it is called linear sensors. So it produces a on and off signal when a magnetic threshold is crossed, that is called as digital switches. Change state when a south pole is detected and remain in that state even if the magnet is removed. So they only turn off when a north pole is present. So this types of sensors is called as latching sensor. And what are the advantage of this Hall effect sensors? Means we can provide contactless and drugged contact, environmentally immune to the system. Next thing, it providing high speed. And in the current sensing, they provide the safe and non-contact way to measure the high voltage lines. And this is the circuit diagram of Hall sensors. Already we have discussed this thing. So the magnetic field energy is passing through this Hall sensor. It will be converted the electrical energy. Thank you. So this is the circuit diagram of Hall effect sensor in detail. Thank you.